Hello everyone, welcome back to my YouTube channel. And this is Netra, and I'm currently studying my engineering in Sri Venkateswara College of Engineering, and currently pursuing in third sem, and the branch is data science. And today I come up with a topic which is related to a subject called maths. So my topic is about ANOVA and the different types of ANOVA. It's like basically first the introduction of ANOVA. An introduction of a ANOVA. The ANOVA stands for Analysis of Variance Technique. The ANOVA, which is ANOVA, stands for the Analysis of Variance Technique, which is used in a statistic to compare the mean of three or more sample for a statistical significance. This ANOVA concept is used to compare the two variables and comparing the significance of the two variables, like which one is having a more significant between them. So to compare the two variable significance, we use a type called as ANOVA, and there are a concept which come across with that is like a null hypothesis and the alternative hypothesis. We need to check for some more things. And the next is, what is ANOVA? What are the versatilities of ANOVA and what are the types of ANOVA? Firstly, ANOVA, it stands for, as I already said, the ANOVA is the analysis of variance, and it is a method for comparing a means of different groups and determining if there is a significant difference. By comparing a two variables, we'll come to know that is there any significance difference between the two variables or the two groups, or which has a more significance value between them. That is about the statistical technique which we use in ANOVA. And the next is versatility. It can be used to analyze the impact of multiple categorical independent and variable of dependent variable. It's like in a variable, which are the variables depending on the categorical analysis and which are not depend on the categorical analysis. And the ANOVA also come up with so many types, including one-way ANOVA, two-way ANOVA, mano ANOVA, for multivariate ANOVA. But in a present engineering, the third sem, we come across with a one-way and the two-way ANOVA. And first thing is a one-way ANOVA. In one-way ANOVA, the cases which are used like it is applicable when comparing the mean of three or more independent groups or a level of significance categorical independent variables. Like the ANOVA is like a table which consisting of a sampling, how many sampling, how many difference between them, and source value, MSS, and the F ratios. These are the kind of values which you inserted in the table. In that table, there are three variables which consist three or more independent groups, which consisting of mainly a single tabular column, which is like one, or either it's a row wise or it's a column wise. That's the one way ANOVA. And the hypothesis testing is like it's used to test whether the mean of a groups are significantly different to each other. In that two or three more variables, it consisting no. To compare any significant difference between those variables, we use a one-way ANOVA. This is about a one-way ANOVA. And the next is two-way ANOVA. It's like interaction effects was like accessing the joint effect of two independent variables of a different variable. It's consisting of both the row-wise and column-wise variables. In one-way ANOVA, it either a row-wise or column-wise. But in two-way ANOVA, it's about whole the row-wise and the column-wise. And the main effect of using this two-way ANOVA is evaluate the individual impact of each independent variable on a dependent variable. It's like compare which are the independent variable and which are the dependent variables, which are the variables which depends on the another variables. That is the way how the two-way ANOVA works. And the assumption of ANOVA, what are the assumptions we come across with the ANOVA is like homogeneity of variance and the independent observation. Firstly, is like homogeneity of variance, which is like assumes that the variance is equal for all groups being compared. It's like when comparing all the variables, all the groups, we finally come with the conclusion that which are the variables are significant and which are the variables non-significant and which are the dependent, which are not dependent. So by assuming the variance is equal to all the groups being compared, and the independent observations like It requires that the observation within across the groups are independent of each other. This is about the assumption of ANOVA and interpreting ANOVA results. It's like as I showing a figure here, this consisting of like this in a tabular column, we consisting of source variations and between the treatments, error value. Yeah, the ANOVA consisting of a factors, replication value, experimental errors, treatment designs, and as I said, the classifications of ANOVA. And the interpreting ANOVA results like effectiveness and multiple comparisons. Effectiveness, like determining the effectiveness of an independent variable on the dependent variable. It's like how much capacity or what capacity that the one variable depending on the another at what amount. And the second is multiple comparisons, assessing which group means are significant different from each other. It's like at or in which place or which position there is a difference between the two variables, like one is significant than another, that at what place, what are the categories which we consider to tell there is a difference between those two variables, and all those are the two interpreting ANOVA results. And the advantages of ANOVA, like efficiency, obviously in this present generation and the scenario, ANOVA plays a very important role in solving some statistical problems, statistical numericals, and as usual ANOVA problems. And the flexibility, let's go with efficiency. The allows for simultaneous comparisons of multiple groups, reducing the likelihood of the type 1 error. It's like by comparing the two variables, it found some error values. So by finding the error values, what is the next step? To reduce the error values or to decode the error values. Right? So that is the efficiency of ANOVA. It decodes or it reduces the errors which are created during a calculations. And the flexibility is like applicable in various scenarios, like including the social science, medical research, and business analysis, which means like ANOVA, it's a all rounder. It's the way it's the multiple uses, like which we used in a social sciencing way, and in a medical research and a business analytics. These are the three main ways or three main places that we use ANOVA, we come across with ANOVA. And nowadays we are like telling that maths it is not using anywhere and all, there is no such users like this thing, so why are they kept in? Actually that's wrong. For every reaction there is a opposite and equal, for every action there is an opposite and equal reaction. So in the same way, each topic has its own efficiency, has its own flexibility, so somewhere it is used, but we don't come across with that. That's it. So this is about ANOVA advantages, and finally I come across the conclusion. There are three key takeaways, like ANOVA is a powerful analytical tool for comparing a mean and understanding a group of differences. To compare the what the mean, what is the differences between the two groups, the ANOVA plays a very important role in placing a present day scenario. And this is about my presentation. And thank you for watching. Please don't forget to subscribe my channel and please like the video. Thank you.